Hello, welcome to this video. How are you feeling about your A-level chemistry exam? If you're nervous, this is for you because I've went through all the examiner's reports and all the past papers and found the most frequent topics to come up. Now this is for all the specifications because chemistry doesn't really change much between the specifications. The content of it is relatively all the same between all the specifications for A-level. Now, I'm not going to waste no more time waffling. I'm just going to go on to the most common topics, the hot topics for A-level chemistry. Now, the first hot topic, which is a topic that literally comes up every single year, is Born-Haber cycles. Now, it basically is just a graph that shows the energy changes that relates to how an ionic substance is basically formed. Now, with Born-Haber cycles and the thermodynamics topic, there are so many definitions that you need to know about. So for example, lattice enthalpy, enthalpy of formation, enthalpy of solution. There are literally so many, and honestly I really recommend you just flashcard these the night before at least and just get to know these so well before your exam, because without knowing these definitions you really wouldn't be able to answer much of the questions. Now you need to know about the arrows. So with Born-Haber cycles there are a lot of arrows. If an arrow goes up, it's endothermic, it'll be a positive value, and if the arrow goes down, it's exothermic, it'll be a negative value. That's so key to remember. Even if you don't understand it, just remember that. Now, also related to Born-Haber cycles, there will tend to be a question next to that question about the Gibbs equation. Now, delta G, so change in Gibbs free energy, equals delta H, which is the change in enthalpy, minus T delta S. T delta S is just the temperature times by the change in entropy. Now temperature, you've got to remember temperature is in Kelvin in this equation. It's not in degrees Celsius, which so many people get mixed up by. And how you get from degrees Celsius to Kelvin is by adding 273. So by adding 273 to whatever your answer is in degrees gets your answer in Kelvin. Now next up is period 3 elements and their reactions. Now a very common mistake people make when it comes to period 3 is that the atomic radius increases across period 3. Now this is incorrect. This is due to the fact that there are still the same amount of shells within all period 3 elements, but the nuclear charge increases, and due to this increase in nuclear charge there is a stronger electrostatic attraction to the electrons in the electron energy levels. Therefore the electron energy levels are strongly attracted to the nucleus, and so forth the atomic radius decreases across this period. Now I know that might sound simple to a lot of you, but honestly it's such a huge mistake that people make, and this was especially said about in the examiner's reports. Now the next thing that comes up more or less every single year is time of flight mass spectrometry. Now you need to know the 4 steps to do with this: ionization, acceleration, ion drift, and detection. So ionization, you need to know that they become ions either by electron impact, which is when an electron bounces onto the atom to knock another electron off to become an ion, or you can say they become ions by electrospray ionization. Now obviously the second step, they're accelerated, and they're all accelerated to the same kinetic energy. Then we have ion drift, and which is basically where the ions, depending on their size, are separated. So the larger ions will take longer to go through the mass spectrometer, and the smaller ions will be a lot faster to get through the mass spectrometer. And then lastly, we've got detection, which basically produces our graph. But I'm not going to get onto it so much in this video because obviously this is just a revision video of stuff you need to revise yourself. Next up is transition metals. Now I know a lot of you will be thinking, oh my god, I hate that topic, because honestly I did too. I think so many people do hate that topic because there's just so much to remember and it's hard to visualize this topic. It's hard to actually know what's going on. It's just a load of equations, a load of colors, and a load of different reactions, and it's honestly, I would say, the hardest topic in A-level chemistry. But this is one that will come up in your exam. 100% it will come up. It comes up every single year. Now a very common question for this topic is the shapes of these complexes. Now you do need to know specific complexes and their shapes, and you do need to be able to work out the shapes of certain complexes. Now I'm not going to get into that right now, but basically if you are unsure, always guess octahedral, because 99% of the time it will be octahedral. Now you also need to know about the differences between monodentate, bidentate, and multidentate ligands. Now all ligands are basically ions or molecules that bond to a central atom and basically donate their electron pair to that central atom. So some common ligands you will need to know about for A level is water, diaminoethane, and EDTA. Now these are common ones you might hear about. Now all a monodentate ligand is basically a molecule or an ion that has one pair of electrons. Now our bidentate ligands are the same as monodentate, it's just there are two lone pairs of electrons present in this molecule or ion. Now our multidentate ligand is basically any ion or molecule with 3 or more lone pairs of electrons to give to that central atom. Now the next thing within the transition metals topic that I'd really recommend you know is the colours of your complexes. Now I know it's really hard to remember the reactions, but at least try to just remember the complexes. It's just a simple 1 mark that you can get in your exam, but honestly if you memorise that and be able to gain that extra mark in the space of about 10 seconds of just looking at that question and knowing the answer, it's such a just good mark to gain for such little effort. It's not really about knowledge, it's just about remembering. Now next up is pH calculations. Now a common thing that tends to come up especially in the AQA papers is it will say why is water neutral. Now I know this sounds really simple because you'd think, oh well it's got a pH of 7, but it wants you to give a specific equation, which is the concentration of hydrogen ions equal to the concentration of hydroxide ions. And that's all you need to say, and that comes up a lot. All you need to put is that equation. Honestly, just remember that. That's an easy 1 mark or even 2 marks, it depends on the context of the question. Now with the pH topic, there are so many equations you need to memorize, and I want to put some on the screen right now, but there are so many to memorize, and honestly memorize them. I spent so long writing flashcards and testing myself with these equations for my A levels, and I genuinely am so grateful that I did that, because trust me, pH calculations come up so much and they tend to have really high marks. So normally a pH question will have about 5-6 marks for that one question, and normally there are a few sub questions to follow that, so it's really good if you can be quite confident with the pH topic, especially the calculations. Now that's basically it for this video. There are so many other topics that do come up so much in all these papers, but I'm just trying to prepare you for the topics that come up the most. I don't want to go over every single topic that comes up in each paper because it will just overwhelm you. These are the topics that I would say really focus on because they have the highest amount of marks, and some of this stuff that I've told you about is quite easy to just memorize. It's not like you need to sit down for hours and learn loads of content. Some of this stuff is just genuinely flashcarding it, testing yourself a couple times, and you'll know it. It's just honestly, it's so useful to gain those extra few marks because it could be the difference between one grade and another grade. So guys, that's it for this video. I really do wish you the best for your A-level chemistry exams. If you need any advice or tips, please do comment down below, and I'd appreciate it so much if you could subscribe to my channel, and I'll see you in the next video. Bye bye.